Hello again. In the previous video, we finished function evaluation and domain. Now we're going to read information directly from the graph of a function. So in this lesson, we will not only do that, but we're going to read function values and decide whether a graph represents a function, identify intercepts, and then state the domain and range of a graph. So let's begin, first of all, with the quick rules for this lesson. So first of all, f of a means read the y value when x is equal to a. Secondly, solve f of x equals k by finding the x values where y is equal to k. X-intercepts occur where y is equal to 0. Y-intercepts occur where x is equal to 0. And then the domain is all x values shown, and the range is all y values shown. So these rules will guide every lesson in this video. Now, example number 1. Example number 1 says use the graph to find f of -2, f of 0, f of 3, and f of 5. Okay, so when we see f of -2, we're looking for the y value when x is -2. Okay, we're looking for the y value when x is -2. So the first thing you want to do is on the graph, you need to travel the x-axis since we're looking for the x is -2. So locate where x is -2. It would be here. So what is the y value in this case? Well, the y value would be here, which is 4. So when f is -2, the output is 4. Simple as that. So when f is -2, the output is 4. Next, when x is 0, okay, that means to neither go left or right. Look at the y value. The y value is 1. So when f is 0, the y value is 1. Next, we want to look at 3. When we need to find f of 3, when x is 3, so when f of x equals 3, so travel the x-axis, find x is equal to 3, then go down, find out the y. Well, the y in this case would be -2. Continuing on, we want to look for f of 5, traveling the x-axis to the right to +5. Noticing the y value is 2. So where f is a +5, the output is a +2. Okay, so the answers are f of -2 equals 4, f of 0 equals 1, f of 3 equals -2, and then f of 5 equals 2. So the main idea is simple. Input values, what goes inside the parentheses beside the function, are x values. And then what comes out are the y values. It's that simple. Now, example number 2. We want to use the vertical line test and then state whether each graph represents a function. So the vertical line test tells us whether a graph represents a function. So a graph is a function if every vertical line touches the graph at most one time. So if I were to draw a vertical line through here, 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 or essentially at any point on the graph, drawing a vertical line will tell me that, okay, well, this point lies on the line, this point lies on the line, this point lies on the line, this point lies on the line. But notice each x indicates it will generate only one y value. So this tells me that after observing function or graph A, this is a function. Okay, so this is a function. Okay, so this graph is a function. Now, again, that means that each x value has exactly one y value. Now let's look at graph B. Notice graph B is a curvature graph. So if we were to do the vertical line test and draw some vertical lines through this sideways parabola, notice this point will be here, this point would 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 be here. So what's the big idea? The big idea is that if, let's just say, As a matter of fact, I'll use 1 as an example. So notice this 1 exists here, right? So if we were to find out what this would be here on this graph, it would be 1, 1, 2. Okay, so this point here would be 1, 2. Then this point here would be 1, -2. Okay, so notice you cannot have an input that generates two different outputs. Okay, you can have multiple, um, you can have different inputs that generate the same output, but you cannot have one singular input that generates two outputs. So this one is not a function. Okay, and we found that out by noticing that it wasn't going to pass the vertical line test. And you can look at graphs and determine that as well. Now let's continue. Pause the video and try this. Okay, so from the graph, we need to find f of 0, and we're going to solve f of x equals 1, and then list the x-intercepts and y-intercepts. Okay, so remember, f of 0 means, or it's read as the y value when x is 0. That's essentially what it means. When f of x equals 1, that means to find where the graph has a y value of 1, because notice y is already given. So x-intercepts happen where the y is equal to 0, and y-intercepts happen where x is equal to 0. So let's go ahead and find this. So at x equals 0, the graph has a value of -1. So when f is 0, the graph has a value of -1, and we found that by here, locating when x is 0, and then noticing that the function is going to be an output of -1. Okay. Now we need to solve f of x equals 1. So when f of x is equals 1, this is essentially saying the function is equal to 1, or the y value would be 1. So where is the y value 1? So what you want to do is, this is the y-axis. So since this is the y-axis, you want to use this as a reference. So the y-axis, or the y value, is going to give me 1. So 1. And then what we need to do is we need to see, when we need the x values where the graph has a y value of 1. So from the graph, 1 point is clearly 2. So if we go to the right, notice that is 2. So x is equal to 2. Okay. So the graph also crosses y equals 1 on the left-hand side, right? So over here, and then also over here, between the number 2 and let's see, or excuse me, between the x value of, like, it's like right here. So between the x value of -4 and the x value of -3, notice it's like somewhere in between, right? So if it's in between that, we'll say, it's approximately x is approximately, we'll say 3.7, right? So essentially what we can say is that f of x equals 1 when x is equal to 2, or x is approximately 3.7. Okay. Now let's list the x-intercepts. Okay. So the x-intercepts occurs where the graph crosses the x-axis. So that means that y is going to be 0. Okay. So when y is 0, meaning that it's not going to go up or down, so it would cross here and it would cross here. So this is -3, 0. And also 1, 0. Okay. All right. And then finally, y-intercept. Okay. So the y-intercept occurs where x is equal to 0. Okay. So that means it's crossing the the y-axis. Okay. So the x-axis, or excuse me, the x would be 0 here. And so this would be the only 0, -1. Okay. So essentially our complete answers are when f is 0, it equals -1. And then when f of x is equal to 1, it's only when x is equal to 2 or x is approximately 3.7. The x-intercepts are -3, 0, 1, 0. The y-intercept is 0, -1. Okay, let's continue. Now, example number 3, use the graph to state the domain and range of in interval notation. Pay attention to open and closed endpoints. Okay, so the domain is the set of all real x values shown on the graph. Remember, I said that the domain by default is always -infinity to +infinity, and this is dealing with the x. The range is always the same, -infinity to +infinity, and this is dealing with the y. Okay, so this is the standard. Okay, that's the standard. Okay, so essentially, when we're doing interval notation, that's going to change. Essentially, so the domain is the set of all real values. The graph begins at x is equal to -5. Okay, so notice the graph here, it begins right here at -5, right? It starts here. And then this is a closed point. So when it's filled in like this, we would say closed, okay? So that's a closed point or a filled in point. So that means that -5 is included. So if you see this, it means it's included in the answer set, okay? And the graph ends at x is going to be -2. And notice this is open, okay? So that unfilled in space is opened, and that's an opened endpoint. And so this means not included. Okay, so if you see the open, not included, you see the closed, that means it's included in the solution set. So what does this mean? Now keep in mind, we have the domain, which is the x, and the y, which is the range. So the domain in this case, the domain is going to be 5, which is included in the set, and then 2, which is not included in the set. So this is how we would write this. Now let's find the range. So the range is the set of all y values shown in the graph. All y values shown in the graph. So as you can see, the lowest y value would be the smallest or the lowest dip in the graph. So the lowest value in this case is -2. And that point is, let's see. So the lowest y value is -2, and that point is closed, as you can see. Okay. So notice the -2 is here, and that is closed. So -2 is included in the graph, right? -2 is included in the graph. And the highest y value is 4. Okay, so the highest y value is 4. So the way we would look at this is, again, both are included. So we would write it as -2, comma, 4. And again, they both are included, which is why we're going to put the bracket around it. The 2 is open, so this is why we use the parentheses over there. So notice again that the open circle at the end affects the domain because it happens on x equals 2. But it does not remove y is equal to 1 from the graph or from the range because the graph reaches a y equals 1 elsewhere, right? So the y equals a 1 elsewhere on the graph. And that is why the range is still -2, 4. Okay. Let's look at some common mistakes, or a common mistake. A student says that the horizontal line test tells whether a graph is a function. Correct the statement in one sentence. Okay. What do you think? So the thing that stands out to me is this right here, horizontal line test. Okay. The statement obviously is not correct, but the vertical line test tells us whether a graph is a function. The vertical line test tells us whether a graph is a function. Okay. So the horizontal line test tells us whether a function is one-to-one. So essentially, if you see this right here, this essentially tells us if um, that essentially tells us that whether or not a function is one-to-one, not whether or not it is a function. So the correct statement is essentially a vertical line test tells us a graph represents a function or not. So again, vertical line test, vertical line test is the function test. Horizontal line test represents one-to-one. Okay. So the final review is when you see f of a, that means the y value when x is equal to a. Okay. When you see f of x equals k, when you see f of x is equal to k, you're finding the x values where y is equal to k. Intercepts occur where y is equal to 0. Y-intercepts occur where x is equal to 0. Domains and ranges are all real numbers, are all x values shown, and the range represents all y values shown. And the vertical line test tests whether or not we have a function. Okay. When reading a graph, make sure you move carefully between the x and y values and inputs and outputs, essentially. Okay. And thank you again. Thank you for watching, and I'll see you in the next video.